All right, so example 2 here is a piecewise defined function. It wants us to graph this. This is the same exact concept as the warm-up. It's just written a little differently. It's written as a piecewise function. So there are 3 separate pieces. We're going to graph each of them on a specific domain. Okay? So these there's a lot of ways you can go about doing this. Here's how I would recommend. I would use substituting points in and essentially making like a table of your values. So we do need to know some basics. Like when you see this equation, hopefully the first thing your mind thinks is that's linear. This is a mx plus b equation. I know that wherever I graph this, it's going to be just a straight line. Now I'm only going to graph it from -10 to -2. So somewhere there's going to be a straight line. We know it has a positive slope. Wherever it's going to be something like this. So I just go ahead and I just substitute these 2 numbers right in to figure out what they're going to be. So if I take a -10 and I substitute it into here, that'd be -40 plus 11 would be -29. So I basically know I have the coordinate -10, -29. So I go ahead and I can plot that. So let's see, this goes by 10 or 2s, so we're here. And then -29 way down here. Now the way you know what kind of dot to plot is look at your signs. Since -10 is included, we're going to use a solid dot. Now when we go to plot our other point, which we're going to find in just a second, we're going to use an open dot because it's not included. So this other coordinate, -2, just substitute -2 in here and see what you get. 4 times -2 would be -8, plus 11 would be 3. So -2, 3 is our other point. And like I said, when we plot that one, go ahead and do an open circle. So -2, 3. This one goes by 3s, which is weird. Okay. Oops, sorry, open circle. I said it and then it didn't do it. And then we can go ahead and connect those. So because we do know that this one is just a straight line. So again, this one's supposed to be open. I made a little dot there, but anyway. All right, so one graph's done. Now we just move on to the next one. All right, this is a x squared. We specifically know exactly what this looks like. We just did this. This is a U-shaped graph that shifted down 1 unit. So we know that its vertex, so it's U-shaped graph, but it shifted down 1 unit. So it's going to be down just a hair here. But we only need to graph this from -2 to 2. So I'm going to do the same exact strategy. I'm going to go ahead and I'm going to say, all right, I know -2. If I substitute that into here, -2 squared becomes a +4. -1 becomes a 3. So that coordinate is actually going to be the same exact coordinate we already plotted. Now notice, now we're going to actually be filling it in because it is a included value. So now this spot is going to get filled in, and that's going to make our U shape. Now we do know that this is the vertex, so we're going to get the same exact point on the other side here. So we could plug it in, but we do know that that's exactly what we're going to get because whatever it is at -2, you're going to get the same value at 2 because we've realized that these have symmetry. So 2, 3 is that other point. All right, so now we've done 2 of the 3 pieces. We move on to the last one. Once again, you look at it, you're like, okay, that's linear. So I'll do it the same way I did the first linear problem. I'm just going to plug in the numbers. So what happens when I plug in 2? 2 plus 1 is 3. All right, now this says that we should do an open circle here, but we've already got a closed circle there. So basically, it's open, but it was already closed, so it's just closed on the graph. And then our last point, this one at 10, 10 plus 1 is 11. So the coordinate 10, 11 will be our last point. So 10, and that's going to be off the grid just a hair, which is okay. And again, closed circle because it's included. And there we go. So now we've created a full piecewise function. And this is the main thing today. If you can do this, then you're going to probably be feeling pretty good. This does have a few follow-up questions. It says, what's the domain and the range? So when they say domain and range, they're talking of the entire function. So the best way to do domain and range is actually once you've graphed it. This is a lot easier to answer now that you're looking at the graph, because now you can say, okay, this domain, this graph, the furthest left it ever went was -10, and then it does everything here, and the furthest right it ever went was +10. So we can go right ahead and we can say this domain is from -10 to +10, just looking at our graph. Now, technically, you can get that from just reading these restrictions right here, too. You can see it's everything from -10, everything's included through here, all the way to +10. So you could get it from that. The range, though, you really do need the graph. It's really hard to find the range without having drawn the graph. So range, if you remember, this lowest value was at -29. This highest value, again right here, was at 11. So my range is going to be from -29 to 11, because those are the lowest and highest values that we ever got. Yep.
Would negative 29 be brackets?
So they should both be brackets because these were both solid dots. So yeah, brackets on everything in this case. But yeah, if one of these was open, like if this had been open, then that would change our these to both parentheses. Let's see what else we got. Also says, when is it increasing or decreasing? So a couple more interval review questions. So this graph, if you look at it, starts off increasing. So this first part increases. So you can look at it or you can just remember what the interval was. That was from negative 10 to negative 2. So it increased from negative 10 to negative 2. And then it took just a quick second and decreased. So that'd be from negative 2 to 0, it decreased. And then everything from 0 onward, it increases, and then it increases at a constant rate. So this whole time it's increasing. So that'd just be from 0 to 10 is another increasing interval. And again, that's just tying in stuff from last section into what we're doing right now. Any questions off that example? All right, then let's jump ahead. So this one, additional example. This one, I wanted to just have the restrictions in here, but they aren't in here. So let's pretend that these restrictions were on here. So negative 4 to negative 1, negative 1 to 2, 2 to 8. So same exact type of problem. This says, find the rest of the piecewise function and graph the function. So we're not worrying about the rest part. We are just straight up just graphing the function. That's all we want to do here. So we're given a function. It says graph it. I just want to do another example of this just so you can kind of see some other things that could happen here. All right, so we've got x squared minus 6. We know what that looks like. That's down at 6. It's U-shaped. But we're only graphing it from negative 4 to negative 1. So I would go the route of find the coordinates. So when I plug in negative 4 squared would be 16. Minus 6 would be 10. So I could plot that. Negative 4, 10. Closed circle because it is equal to. And then when I plug in a negative 1, what do I get? Negative 1 squared is positive 1. Minus 6 would be a negative 5. So negative 5 at negative 1. So negative 1, negative 5. And this one, we want to go open circle. So open circle right here. Now remember the shape of your graph. Sorry. This is a U-shaped graph. And we know the vertex should have been down here at 6. So you know the shape of this has this little curve. So when you draw it, just draw the little curve as best you can. Basically recognizing that it's not just a straight line. Doesn't have to be perfect. That's fine. All right. This next one always gives people fits, but it's actually the easiest one. This next one says 8, meaning you always just get 8 out for any of these numbers. So literally these coordinates would be at negative 1, you just get 8. And at 2, you just get 8. So any number between here, we get 8. It's going to be just a flat horizontal line there. So at negative 1, we are up at 8. And this one, looking at the sign there, should be a closed dot. And then at 2, we are also at 8. But this time, open dot. So then we just connect those. It's a nice, flat, constant part of a graph. So you're saying, hey, for that spot, the graph is just always at 8. Okay, and then our final one here, do the same thing. This is linear. So this is an mx plus b. There's just no plus b part. So it's just a slope. So again, I'm going to look at what happens when I substitute in 2. So these ones, we're going to get some decimals, which is okay. So 2 times negative 1/5 is negative 2/5. And then for 8 times negative 1/5 is negative 8/5. Now, if you really struggle or you really hate fractions, you can convert those to decimals if you want. You know, that's negative 0.4. This would be negative 1.6. Feel free if you want to divide those, you can. If that makes it does make it easier to graph, I'll be honest. So now let's go ahead and plot those points. And again, we know this one's just linear. So at 2, we're at negative 0.4. So, you know, it's just down a little bit, but it should be a solid dot. And then at 8, we are at negative 1.6. So, you know, not quite to the line there. And this one should be an open circle. So a very slight negative slope, which makes sense because it says it's negative 1/5. And there we go. These, as you practice them, you do get better at them. You get more familiar with how I should make the graph. But trust me when I tell you, use these as plotting coordinates. If you do this to just find 2 coordinates and then know what the shape is, know whether it should have been U-shaped, whether it was constant, whether it was linear, It's going to make drawing the line in nice and simple. Okay. Any questions as far as that process goes? All right. So now the other part of this is, can you go in the other direction? Can we go backwards from this? So this is now giving us a function and saying, can you come up with what the rule would be? So yeah, we can. So we'd say our function is f of x, and then take a look at it and see how many pieces you have. In this case, like how many different sections are there? This is 3. You have a linear one here, a linear here, and a constant there. So there's 3 specifically different sections. So we know we're going to need 3 equations. So now we need to write those. Now these are all linear, so they all should be mx plus b style equations. So let's start with this one here. This one looks like it crosses at -4, so its y-intercept is -4. And then by counting the slope, because we know this point right here, looks like we have to go up 3 and right 1. So that looks like a slope of 3. So when I see that line, I'm thinking that's 3x minus 4. Like that's just by looking at that line, I can identify the slope and the y-intercept, and I can come up with what it is. So that's going to be my first equation, 3x minus 4. And now just list the domain that graph exists. So this graph exists from -2 to 1. So using the same skills we've used before. So this is from -2, less than or equal to x, less than 1. And again, the way I decide my signs is based off of, are they solid? If they're solid, it's equal to. If it's open, then it's not equal to. A lot of little tiny details on these types of problems. Okay, so now I can move on to my second line. So once again, now I'm looking at the second line. This one, they give us some coordinates here. So we have the coordinate 5, 8 and the coordinate 1, 4. So we can look at those and we could count our rise and our run. So we can see that this is a rise of 4, to get from 4 to 8, but it's also a run of 4. So this graph is going to have a slope of 1. So we got like 1x. Also, it'd be really nice if we knew the y-intercept. So if you go and you use the slope to go back 1 and down 1, if you were at 1, 4, you'll see you're now going to be at 0, 3. So even though this graph doesn't technically have a y-intercept, we want to know what it is to write our equation. So we can come up with that y-intercept by looking at the graph. So that equation, I would just call it x plus 3. You really don't usually put the 1 there. So we find the slope, we find the y-intercept by looking at the graph, then we can write its equation. And then now, include the domain. So what's our domain here? Just look at the coordinates. It's from 1 to 5. Those are the x values that graph exists. So it's from 1 to 5, and they are both solid. So we can go both or equal to's. And then our final one is what I told you. Anytime you have a constant flat graph, this should be the easiest one. This constant is just at 8, meaning this graph is always 8. And anything from 5 to, it looks like 8. So from 5 to 8, both solid dots, so they can go both be or equal to's. And that's it. So we're going to save this last problem. We'll pick it